3e. In this figure, quad is a quadrilateral. This is quad. Quad is enclosed by the rectangle rect. This means that each vertex of quad is on a side of the rectangle rect. Segment QA is parallel to two of the sides of the rectangle. The length of QA is 18 and the length of EC is 13. What is the area of quad? So what I'm going to first do is label the information I have. So, okay, we do know this is 7QA, so it's parallel to two of the sides of the rectangle. That would be this side, this side, this side. So it's parallel, okay. And the length of QA is 18. Well, if it's parallel and each of these points are on the sides, then this side right here would be 18. This would be 18. This would be 18. The length of EC is 13. Well, if EC is 13, RT would also be 13. So what is the area of quad? Well, as you can see here, quad is made up of the areas of triangle QUA plus the triangle QDA. So these two triangles added up together equals what we're trying to find. And remember the triangle area property? I mean the formula that was base times height times 1/2 equals area. So that's something you need to keep in mind here. All right, now we have triangle QA plus triangle QD. Well, I don't know what to do with that. All right, we have an equation, but it doesn't really seem useful. That's because this is just the beginning. Using this, how can we find the area of triangle QUA? When we know the base, that's 18. And we know that it has to be times by 1/2. And we have to times it by its height. But do we know its height? Do we know the segment of this dotted line right here? What is this height? Well, since we don't know, why don't we just set it? I'll call this H1 to represent height 1 almost. So I'll call this height 1. And no worries because we're going to find that out later. Now that's going to add, now it's the same for QDA, triangle QDA. So we know the base, it's almost flipped around. So the base is 18 times 1/2, of course, times, we don't know this height. So what I'm going to do, just going to name it H2 for height 2 times height 2. So I'm just going to go ahead and simplify. And notice how we use substitution in our calculation. So substitution is a very, very important concept you have to grasp from this problem. Substitution is taking, for example, what we did was we knew the area and we're going to substitute it with the values using the base times height times 1/2 property. So 18 times 1/2 would equal 9 times H1. 9 times H1, and plus this would also be 9 times, well, H2. And now we're stuck again. Now, how do we find this? Well, look. Do you see a common factor in each of these terms? Yep, 9. So all we do is factor it out, and then inside the parentheses is H1 plus H2 using the reversed distributive property. Remember that if you're not mastering the distributive property, go ahead and master it because it's something very, very important. And if you don't know the distributive property, well, I'm sorry, the rest of the problems would be a hard journey, friend. So go ahead and go and master the distributive property. That would also be in the description down below. So now we're stuck again though. We have 9 times the sum of H1 and H2. This is where the problem comes in. We know that this side length EC is 13. Doesn't this just add up to 13? Doesn't H1 plus H2 equals 13? Of course, exactly, it does. In fact, it does. So we can substitute that in using the word substitution. That's a very, very heroic word right now. And we have 9 times 13. Now that's all numbers, all we have to go and do is just multiply. So 9 times 13 is equal to 117. Therefore, the answer is 117.